So we are doing the solving of differential equations for y today, for like the general equation. So like last class we talked about the slope field and what it looks like if we found the slopes at all of those x, y value points. This class we're going to actually like be given an equation like this and we're going to solve for y, okay, by taking rid of the derivatives and all that kind of stuff. So do you guys remember implicit differentiation? Like if I gave you something like this and I said differentiate this implicitly, do we remember how to do that? That'd be like doing the derivative of both those things, but with respect to what variable? With x. So let's take the derivative of both these things with respect to x. So this becomes 2x, and then technically it's times dx over dx, right? But what is dx over dx? Just 1, so that's really not need to be there. And then if I took the derivative of 2y, that's 2 times y times dy over dx. And then what's the derivative of 9? 0. Okay, now after we did the derivative, what did we do next? We solved for dy dx. Okay, so let's get dy dx by itself. So I move that negative 2x over. And then I can divide by 2y on both sides. And my answer, dy dx, is equal to negative x over y. Okay, now this is still not solved for. This is still a differential equation in terms of x and y, right? So what we're going to talk about today is I'm going to be able to integrate both sides to get y by itself, okay? So if I integrated this right-hand side, can I do anything there with x's and y's? No, so there is this tool that is called the separation of, that's what it's labeled here, separation of variables, okay? So we can separate these into y and x's by, if I was looking at this one here, I could just cross multiply these. This dy is a thing by itself, dx is a thing by itself. If I cross multiply these, this is actually, I think, first example, no, it's very similar too. But if I cross multiply here, this would become y times dy, and then on the right side, that becomes negative x times dx, right? Okay, so now if I wanted to, I could integrate this. Integrate both sides, because what you do to one side, you got to do to the other side. Basic algebra. And if I integrate y, I end up with y squared, right, over 2 plus c. What do I end up with on the other side? X squared over 2 plus c. Okay, now can I just cancel these c's out? No, because do I know what that c is equal to? No. So what I want to do now is I want to solve for y. Okay, so let's get my x's and y's on one side here. So this becomes x squared over 2 plus y squared over 2. And then I'm just going to move that c over to the other side. Okay, do we see kind of how this and what I have up here look very similar? Where we started with and what I've got here in blue? How can I make it look even more similar to what we started with?
Both sides by 2.
Yeah, multiply everything by 2. If I multiply everything by 2, I'm going to write my answer up here because I ran out of space. I would end up with x squared plus y squared is equal to, well, 2 times c. We're not going to write it as 2c. 2 times a number is just still going to be a number, so I'm going to write it as equals c. Okay? Now, these things right here are the exact same. However, this right here is my exact solution, like it's an exact answer, whereas this is a general equation because it's just equal to a constant, right? There's a constant in your answer. Today, we're going to focus on just finding the general solution in terms of y instead of finding the exact solution, okay? Does that kind of full circle kind of make sense of what we're doing there? It's like a circle. It's just like recycling back to what we were doing originally, okay?
Like a circle, pointless.
That was a good one there, Jacob. That was a good one. Okay, we're going to go through all 4 of these examples, and we're just going to do the separation of variables first. Then we're going to do a few practice problems on whiteboards, and then we'll come back and actually solve these, okay? So, first one right here. We are going to separate my variables because right now I have x's and y's on one side of the equation, and I want only x's on one side and only y's on the other, okay? If I want to get rid of this dx on the bottom, what should I do? Yeah, I can cross multiply. Okay, if I cross multiply, I end up getting just x squared times dx is equal to what? Y times dy. Okay, have we ever had an x squared plus dx or a y plus a dy? No, the dy and dx is always times that entire quantity, okay? So we're going to leave that like this for right now. We'll come back and solve it here in a bit. Because now I've got x's on one side, y's on the other. Number 2, I've got dy over dx is equal to sine of x times y squared. So let's get rid of this dividing by dx. So I'm going to multiply by dx on both sides. And then I get dy is equal to sine of x times y squared times dx. And how do I get the y squared to go away? Divide it to the other side. Okay, so this becomes 1 over y squared dy is equal to sine x dx.
So what's the general equation again?
I've got y's on one side, I've got x's on the other side, right? Okay, we're going to pause for now. We'll come back and finish it here in a bit.
Why are we moving on?
Because I want you guys to get practice with separating your variables first. Okay? I got to get rid of this dividing by x dx. So times by dx on both sides. And I've got dy is equal to xy dx. How do I get the y to go away? Divide it out. And I get 1 over y dy is equal to x dx. And last separation here before we do a little practice. Thoughts on what we'll do here first?
Factor?
Yeah, factor. Because if I multiply by dx on both sides, I wouldn't be able to take that y out, right? So on the right-hand side here, what can I take out of both of those terms? 2x. Okay, now can I cross multiply here? Multiply by dx on both sides. And I get dy is equal to 2x times y plus 2 dx. And I got to get rid of my y plus 2's. So we'll move that over to the other side by dividing. So I've got 1 over y plus 2 dy is equal to 2x dx. Okay, again, we can never have like a plus dy or a minus dy. If something like that were to happen, and that's the only way that we can think of to separate the variables, this would be an inseparable equation. Okay, so we wouldn't be able to solve it using this method. Okay, so right now I want you guys to go grab either whiteboard markers and erasers. You can write on your desk. You can write on Notability. If you want to go up to a whiteboard and write on a whiteboard, that's fine. I'm going to give you guys 6 problems, 3 at a time, to try and to try and separate your variables out, okay? I'm going to write the answers up here of what you should have gotten. For number 1, we should have gotten 1 over negative 4y plus 5 is equal to, oh wait, that's also times dy, and that's equal to dx, right? Number 2, what do we get for number 2? 1 What'd you get?
Do you have to put 1 over, or can you just put dy over y squared?
You could put dy over 1 squared, or sorry, y squared, but I like to just like kind of write it separately because then we're integrating this piece and we don't get confused by the dy piece, you know? And then that equals 2x cubed times dx. And then number 3, if I were to subtract, right, because that's like what your gut tells you to do is like to subtract something, then I'm going to end up having multiple variables, or if you also tried to distribute this dx, then I have a dx, but it's also being multiplied by both things. So there's no way that I can separate my x's on one side, my y's on the other, right? So this would be not separable. Does not exist. That's fine too, okay? All right, other 3 problems that I want you guys to try out. Okay, here's your next 3. My hint to you is make sure you check how it's ordered. It's dx on top for 2 of these. And then I left a hint there for number 6 if you're stuck with how you can separate those variables. Okay? Okay, for number 4, we should have gotten 1 over x minus 3 times dx.
Is it okay if we just do dx over this thing?
Yep, that's fine. And then that equals 2y plus 1 times dy. All right. What do we do for the number 5 here? Factor out an x, right? So that becomes x times 1 minus y squared. So this would become 1 divided by 1 minus y squared. dy is equal to x dx. And then lastly, number 6, if I were to rewrite this, this would become e to the y divided by e to the 3x. It is not negative, okay, down there. And then if I were to cross multiply this stuff here, this would become e to the 3x times dx is equal to e to the y times dy. Okay, does that kind of make sense how we're splitting these into x's and y's and when it can and cannot happen? Okay. So again, if you find things like number 3 up here where you're trying to add 2 things together and you can't move one over to the other side by multiplication or division, then that would be a not separable problem, okay? All right, go ahead and put those whiteboards, markers, erasers away and then head back to your seats. We'll take a quick little break and then we'll do those 4 problems solved out. So now we're actually going to finish solving them for y, okay? So for number 1, this is what we ended up with last. If I integrate both sides, I need to evaluate those with respect to that variable, right? So if I integrate x squared, I end up getting x squared x cubed divided by what? 3 plus what? C. If I integrate y, I end up with y squared divided by 2 plus c. Okay, again, these c's are not just going to cancel out. If I move one c to the other side, that just combines it and makes it a different constant technically. So technically this is like constant 1, constant 2. This next constant would be constant 3. They're all different. None of them are the same. But if I want to solve for y, I'm going to move that constant 2 over to the other side. So this would become x cubed over 3 plus a new constant. We'll call it 3. Again, you don't need to put those little sub numbers there, but if it helps you keep them straight, you can. And then that's going to equal y squared over 2. And I'm solving for y at this point. This is just algebra. What do I got to do? Multiply by 2. Multiply this whole thing by 2. So I get 2/3 x cubed plus, again, this is 2 times a constant. Am I still going to have a constant? Yeah, so I'm just going to write plus c. Technically, it's like our 4th constant there. And then that's equal to y squared. Last step, solve for y. Square root both sides. And when I'm solving an equation, I don't have just the positive version. I have the positive or negative version of that answer. So this will be my final answer. Again, that's our general formula. We'll talk next time about how to solve for an exact formula, but you're going to have to be given some information that we don't have in this problem. Okay, questions on that one? Okay, moving on, number 2. Number 2, I'm going to integrate both sides here. If I integrate the left, integrate the right, this is the same thing as y to the negative second power, right? So what am I going to get when I integrate y to the negative second power? Negative y to the negative 1 plus c. And what do I get when I integrate sine? Negative cosine of x plus c. And I want to get y by itself, so I'm going to move that plus c over. It's just going to become a constant on the right-hand side. Okay. And then could I get rid of these negatives here? Yeah. So I'm going to divide by a negative 1. So I get y to the negative first power is equal to cosine of x. And then again, it's still just a constant, so yes, technically it became a negative, but it's still just a constant, so we're just going to leave it as plus c. And then how am I going to solve for just y here? Yeah, I could think about this. There's like a few ways you can think of it. This is technically like 1 over y, right? Is equal to cosine of x plus c. So I could multiply by y on both sides, right? Or could I also just flip the reciprocal on the right side? Are we okay with that? Yeah. So there we go. That's your final answer. But your plus c does need to be in the denominator there. Okay. Number 3, integrate 1 over y, integrate x. What is the integral of 1 over y? Natural log. Absolute value of y plus c would equal x squared over 2 plus c. And again, I'm getting y by itself. So I'm taking the natural log of y is equal to x squared over 2, and then that c is still just going to be a constant there. We just moved it over. And then if I'm given an equation like this and I want to solve for y, what am I going to do?
Roll the log?
Yeah. So I'm going to make this e to the natural log and e to that whole power of x squared divided by 2 plus c. Those are going to go away. And then I'm going to be left with y is equal to e to the x squared over 2 power plus c. And we can simplify this a little bit. If I'm adding exponents up there, that's going to be the same thing as multiplying the same bases, right, with those exponents. So I could rewrite this as y is equal to e to the x, excuse me, x squared over 2 times e to the c power. Do you guys agree? Okay. Because if I've got the same base, I can add the exponents. And now if we think about this, e to the c, that's just going to be another number, right? So we can just call that a constant. So now my answer is just y equals the constant times e to the x squared over 2. All right, number 4 is almost identical to this, except for it's just slightly different. So I'm going to let you guys try out number 4 real quick, and then I will put the answer up here, and then you guys will have work time. All right, we should have gotten c e to the x squared minus 2. Yes?
Yes.
Wonderful. All right, that is it for you guys for today. So you got 8 problems on Schoology, which actually are just attached to these notes, so you can't grab it from Schoology. But answer key is posted, so you can check your work as you go. You probably can get this done in class, or if you want to work on corrections, you can also work on corrections right now as well. I would like those to be done by Friday if possible, but if not, I also understand that because, it's 2 days from now. So.